Hello, everyone. Thank you for joining us today. We have our USGBC Central Pennsylvania Decarbonizing Commercial Kitchens webinar. We have a terrific presentation prepared for you today by Heidi Kunsch and Chef Chris Galarza. We will have a question and answer session at the end, so please add any questions you have during the presentation in the chat, and we will address them at the end. Before we start, I wanted to remind everybody who is seeking GBCI and AIA credits to please make sure you provide me with your correct number. If you have not entered your GBCI and AIA number on Eventbrite when you were registering, please make sure you email me. My email is on the screen, rebeccabentley@usgbc.org. And if you're unsure if you entered it when you were registering, you can send me an email and I'm happy to check for you. We want to make sure you get the credit if you attend today, so please double check that you provided that information to me. Okay, and now I will pass it over to Heidi Kunsch to kick off the presentation.
Okay, good afternoon, everyone. Can you hear me, Rebecca? Okay, great. So my name is Heidi. I work for the Pennsylvania Department of Environmental Protection in our Energy Programs Office. And today I'm just going to give a brief intro about our program called Cooking in Healthy Electrified Commercial Kitchens, which is an acronym for CHECK, the CHECK Rebate and Education Program. Next slide, please. So what is the DEP Energy Programs Office? All states have what's called an state energy office that receives annual funding from the U.S. Department of Energy to carry out various incentive programs and education outreach programs aimed at energy conservation and energy efficiency, renewable energy technologies, energy assurance, climate change. And we do all of this work, not just as a result of the funding that we receive from the U.S. Department of Energy, but also via partnerships that we have with various local governments, businesses, nonprofit organizations, higher education institutions. Our office is also currently receiving a lot of funding from the Bipartisan Infrastructure Law, as well as the Inflation Reduction Act. So we are quite busy these days here at the Energy Programs Office at DEP. Next slide, please. So we're using our U.S. Department of Energy funding to implement this CHECK Rebate and Education Program because we want to start to electrify our buildings. And this is our first foray into building electrification. And we're starting with commercial kitchens. So why electrification? The best way to achieve deep decarbonization or to make the biggest cuts in our greenhouse gas emissions is to green our electric grid, which means using more renewable sources of energy at the electric power plants, and then electrifying our buildings and transportation systems at the same time, while also emphasizing the importance of energy efficiency and conservation. So the table that you're seeing here is from our 2021 Pennsylvania Climate Action Plan. This figure shows the various strategies that were modeled for reducing greenhouse gas emissions in the Commonwealth. And as you can see, greening our electric grid, electrifying our vehicles, and electrifying our buildings were of utmost importance. They give us the biggest bang for our buck with reducing our greenhouse gas emissions in the Commonwealth. So this is a reason why we want to electrify our buildings. And I am going to be talking today about commercial kitchen electrification, but I did just want to let you know that for homeowners in Pennsylvania, as well as homeowners throughout the country, via the Inflation Reduction Act, there are going to be a series of rebates, one focused on home energy efficiency rebates and another on home electrification. where you can get rebates to install electric heat pumps, electric heat pump water heaters, and then also induction cooktops in your homes. So here in Pennsylvania, those rebate programs will not be available until the end of this year, early next year. So we're looking at, at least another 9 months till this is available. But just wanted to mention that as it's an FAQ right now. Next slide. So why kitchens? Many of you will recall this scene from Ratatouille, where the critic Anton Ego goes into Cousteau's restaurant, and he's about to eat this ratatouille, and he takes the first bite, and he has a flashback to when he was a child eating, his mother's ratatouille. And that's the reason why we started with kitchens. Kitchens are, if there's a table that we can all gather around our mutual love of food, and also our passion for the environment and public health. These are all benefits, reducing environmental impacts, public health benefits of induction cooking. So Chef Galarza is going to share with you about those many benefits today. Next slide. So CHECK is an education and a rebate program. It's 2 components, and it is a pilot. We are trying to see what the interest is in kitchen electrification in Pennsylvania. So it's just a demonstration program. We may enter into a year or 2, but we're just trying to gauge the interest out there. And our goal is to help commercialize kitchens in Pennsylvania and make them become healthier places to work via energy efficiency and electrification. And in order to apply for our rebates, you either need to attend an in-person induction cooking workshop that we're hosting, or else attend one of our online trainings. And this one today would count, of course, as an online training. Our rebate program was officially launched on October 1st of last year, and we have plenty of rebates remaining. So please consider applying or having your clients apply. Next slide, please. I'll be introducing to you shortly our education contractor for the CHECK program. His name is Chef Chris Galarza of Forward Dining Solutions, LLC, which is a small business located in southwestern Pennsylvania. So right here in our own great Commonwealth, we have an expert on kitchen electrification. There are 2 educational training opportunities offered through CHECK. One is actually completed. We recorded 3 hour-and-a-half-long webinars with featuring Chef Galarza this past fall. And all 3 of those webinars were recorded and are posted on our CHECK webpage. And you'll see a link to that CHECK webpage later in the presentation here. Also, we're going to be conducting in-person induction cooking workshops starting on March 10th that you can register for. Here I was at Greenbuild 2022 last year in San Francisco. This is a picture of another chef that is an advocate of kitchen electrification and knows Chef Galarza very well. And that is an induction wok he's using there. And I got to see firsthand the excellent performance of induction cooking at this induction cooking workshop at the U.S. Green Building Council's annual Green Build Conference and Expo last fall. And it's actually at Green Build 2021 where I first learned about Chef Galarza and was really inspired by his presentation on commercial kitchen electrification. And it inspired me to create this program. So I hope he will inspire you today as well. Next slide. So here is the 3 workshops that we'll be hosting in Pennsylvania. March 10th is our first one in the Pittsburgh area at Chatham University Eden Hall campus. Then we're having one at a Living Building Challenge building, Refarm Cafe in State College. And then finally in the Philadelphia area at Swarthmore College on May 23rd, these are pictures of the induction cooking kitchens here that you see on the right-hand side. The top one is Chatham University, Eden Hall, and the bottom one is the Farm Cafe in State College. So you can register for these workshops on our CHEC webpage. Next slide. So the rebate program has approximately $150,000 available in funding. We are issuing $5,000 max rebates per applicant. They are available on a first come, first served basis. And we do have a set amount of those rebates reserved for buildings that are located in disadvantaged or environmental justice communities. The buildings can be existing buildings, or they can be brand new construction projects. Eligible applicants include K-12 schools, higher education institutions, not-for-profit healthcare facilities, and 501c3 nonprofits geared toward community services, such as shelters and food banks and soup kitchens. Next slide. And so here's a listing of the equipment that is eligible for a CHEC rebate. Energy Star certified commercial cooking equipment is eligible. Dishwashers are not eligible. Refrigerators are not eligible. This is a cooking equipment program only, and ancillary equipment for cooking equipment, such as ventilation hoods. So they are big energy guzzlers in our commercial kitchens. So we are funding demand control kitchen ventilation systems, as well as induction cooking equipment, specifically induction ranges and cooktops, woks and griddles. And then finally, any electrical infrastructure upgrades that are necessary to accommodate the additional load of induction cooking equipment. It can't be your Energy Star certified cooking equipment that's adding to your electrical load. It needs to be your induction cooking equipment. And you can see the various rebate amounts on this. Next slide, please. How to apply. So there is an online application system that you would use to apply. There are step-by-step application instructions on our CHEC webpage. I encourage you to use those so you don't have any technical difficulties. The rebate program is currently open till June 30th. That being said, and I can't put this in writing, but it is my intention to extend this program to December 31st of 2023. We would accept rebate applications through December 31st and expand the eligibility to restaurants in the Commonwealth of Pennsylvania. Neither of those things, extending the program to December 31st or expanding it to restaurants, is currently approved internally here at the state. I need to get those approvals still. So that's why I'm not putting this in writing, but I am letting you know that is hopefully my intention here, but I have to work on getting those approvals. And then, so in order to apply, you would upload your product specifications and your price quotes into the online application system. Next slide, please. And then upon issuance of your rebate voucher, as long as the application is successful, you will be able to utilize that rebate voucher that you receive for up to 180 days or 6 months. We're allowing you time to get that equipment shipped to you and installed, because there are some shipping delays out there, as everyone knows. And then following installation of the equipment, you need to send us some before and after photos, and then proof of payment and the equipment invoice. Next slide, please. So for more information on the rebate program, the application instructions, the rebate guidelines, and also a link to register for our induction cooking workshop, you can go to dep.pa.gov/commercial buildings. And then if you'd like to be placed on our CHEC email distribution list, just shoot that resource account an email and we'll get you added so that you can be notified if and when we expand eligibility of the program and or extend the rebate application period. Next slide, please. And this is my last slide, but this is hot off the press from the US Green Building Council for all of the LEED fellows, LEED GAs, and LEED APs out there. There are 2 new alternative compliance paths in the LEED energy and atmosphere category to incentivize projects that reduce on-site combustion. These are brand new. The first link shows the intricacies of the ACP for going the prescriptive path. If instead of doing energy modeling for your project, you're doing the prescriptive path, you can get a maximum of 1 additional point for using induction cooking equipment. And then also the second link is for the ACP. If you are doing energy modeling for the building, there is a path to still getting a point or 2 for having reducing on-site combustion via induction cooking. So please take a look at those brand new ACPs as to how you can get your clients more points in the LEED rating system for building electrification in general, not just induction cooking. Next slide. And this slide is just my direct contact information. Feel free to email me with any questions about the check rebate program or our upcoming workshops. And now, without further ado, I would like to introduce our feature presentation. Chef Chris Galarza is an entrepreneur, author, public speaker, and podcaster, renowned for his work in kitchen electrification, and is the founder of Forward Dining Solutions, LLC, a Pennsylvania-based small business. As the country's foremost expert in commercial electric kitchens, Chef works with governments, manufacturers, brands, designers, and other chefs to create lasting, sustainable kitchens and culinary ecosystems. Chef?
Thank you. Thank you, everybody, for being here. Let me just share my screen here. All right, so without further ado, we're just gonna talk about what these solutions are that exist. So quick introduction to the company. Heidi did a great job introducing me. Thank you very much. But quick intro to the company is that we are a company focused solely on commercial kitchen electrification. We're the first and only firm in the country that does this. We're also a chef-owned company with experience in all facets of dining, from 5-star, 5-diamond resorts, where we worked with master chefs and culinary Olympians, and all the way down to small-scale restaurants and independents. We're experienced with working with multidisciplinary teams to achieve sustainability goals, and we are now able to fully decarbonize your entire building through our partnership with Block Power, as well as offer financing and all of this. Ultimately, we're here to help designers sustainably build kitchens of the future, and we're a voice for the culinarians in these rooms where folks are making decisions about what to do with kitchens. But before we go any further, let's do some housekeeping. This is GBCI course number 092-002-7235. The USGBC will report credits earned by attendees to AIA CES. Certificates of completion will be provided to course attendees upon request. This course has been approved by the AIA, and the reference number is 2023 CPA 0222. This course will not be used to promote or market our company's services during the educational portion of the course. And please add your name and email address to the sign-in sheet in order to receive credit for this course. This educational course will cover the topic of sustainable food service, looking particularly at how all electric kitchens, specifically induction cooking equipment, can transform commercial food service. High-performance electric kitchens have a considerable amount of energy compared to the traditional gas kitchen. Eliminating combustion from the commercial kitchen also dramatically improves thermal comfort, indoor air quality, and production. The course will delve into these topics and provide the audience with real-world examples. At the end of this course, participants will learn about the William J. Worthen Foundation's free resource, the Building Decarbonization Practice Guide, and where to find it. You will also understand why electrification is an important step towards decarbonization. Participant will understand how and why electric cooking equipment is more efficient than natural gas equipment. We'll also learn how removing combustion from kitchen improves indoor environmental quality, and also become familiar with a range of all-electric food service strategies and their implications on energy performance and carbon emissions. Now that we got that out of the way, we've heard a lot about what's been in the news lately about like gas stoves and electric induction and all these different things. But really the conversation started back in 2019 when Berkeley passed the nation's first all-electric building ordinance. This was honestly revolutionary at the time. At the time I've been working in an all-electric kitchen now for 4 years, give or take. And despite knowing how much better it was, I had no idea that you can actually mandate this. It was a pretty radical step, and one that has quickly kind of taken life of its own in just 3 short years. By the end of last year, 94 local governments have adopted these policies. I'm told that we are at 99 right now, which spans 9 states, including Washington, D.C. That's going to affect 31 million people, which is roughly 10% of the population, which is going to be a potential health savings of $34 billion. And the average household savings of greenhouse gas emissions will be 59% over 10 years. So pretty robust in just the 94, or at the time, 94 local jurisdictions that made this change. Excuse me. So before we go any further, let's recontextualize the argument, right? A lot of folks have an emotional connection to how we cook. So let's imagine a world in which everything around us wasn't electrified already, and what that would look like. Now, I know that little video may be silly to a lot of folks, but the truth is that there's a lot of people in this country that don't realize that everything around them is already electrified, right? We've never seen a gas-powered microwave or a gas-powered air blower, but the truth is that 99% of our lives are electrified already. It's just a few things. Like if you look around in your home, you're really looking at like 3 or 4 things on average that are gas, your gas stove being one of them. So why are we holding on to it? So what are electric kitchens? What is the difference between electric resistive, electric induction? How does this work? Well, let's first talk about what it's not. So obviously it's not gas, right? It's not these coils that we all know and loathe, which is electric resistive, or it's not radiant, which is what I call the coils 2.0. This is the one that has the glass top that folks oftentimes confuses for induction, but induction will not glow red. Induction is actually a safer way of cooking. And it's a way of cooking using electromagnetic currents to heat your cooking vessel. As you can see, as an example, the pot of water is boiling, but the ice cubes aren't melting. The chocolate here is melting, but the chocolate outside of the pan is not. So it's an easy way to meeting your sustainability goals, as well as saving yourself some money, which we can go into later. So the way it works is we take this tightly wound copper coil and we send electrical current through it. And as it's going around and around in circle, it's creating what's called an eddy field, which is an electromagnetic field that oscillates the ferromagnetic molecules in the pan, making the pan itself the heating element. That molecular friction that's happening while those molecules are jumping around is what heats up the pan. The easiest way to imagine this is think about your microwave at home. When you turn it on, it sends these little waves that excite the water molecules. And as that water molecules are jumping around, it creates the friction that heats up the food from the inside out. So the difference of how electric resistive works is that we have to take in this electrical current, convert that current into heat energy by resisting that current, and then that heat energy then makes it to the pan. Once the pan is hot, then the food gets hot. This is a way of bypassing all that and going, to use a car metaphor, power directly to the wheels. So pros and cons. Induction Pro, very high efficiency. We're talking 80 to 93% versus the at best 35% you'll find with gas stoves. It heats up very, very quickly, as we just talked about. It has precise temperature adjustments. If you look over here, these little windows here are actually temperature gauges. So as a chef, I can set these to exact degrees that I want for a recipe. So if I'm going to, ask Heidi to, sear off some flank steak for an event, I can say set it to 435 and sear them at 4 minutes on each side. So that way I know every single flank steak, no matter the size, is exactly the same. And then from there, we have a temperature set in the oven, set the timer and the degree that I want the internal temperature to be. And then we have consistency all the way around, as opposed to looking at your gas griddle and there is no consistency. It's just, it's just a dial that you just kind of guess on where it's at. And then, her sear might be different from my sear. We have that inconsistency that we've all experienced in restaurants. This has, like I said, precise temperature adjustments. There's no idling equipment. So this induction range, for instance, doesn't stay on with the pilot lights. It only turns on when the pan hits it and you turn that dial. There's no combustion, which means there's no carbon monoxide, and we'll touch on that in a little bit. And there's a dramatic improvement of thermal comfort. The kitchen is far cooler. We'll again touch on that as well, and it'll also extend the life of your pots and pans, which means no more warping, no more soot buildup, no more black pots and pans. These pots and pans that you'll have will last forever, or as long as you want them to. When I was at Chatham, the pots and pans we had were the same ones that we opened up with, and that was almost 6 years old, and they looked just like we did when we took them out of the box. They were pristine. Oftentimes every year or so you're looking to replace your pots and pans because of that soot buildup, because those pots and pans won't quite fit right. They'll kind of roll or they won't sit flat, and that's because fire is a very violent thing to heat up with metal, and it'll warp that over time. The con is the initial cost. Like, how much is this going to cost me? Oftentimes lately we've been seeing a temperature difference of about $10,000. What's the compatible cookware? Are you gonna have to replace your pots and pans? Truth is, you might, because you've been cooking on gas, your pans are warped, or they're probably aluminum or something like that. If they're aluminum or pure copper, they're not going to work. So oftentimes people just end up replacing it. And also, what's the electrical capacity, the retrofit hurdle for all of this? How are we going to get power to the space? Do we have enough power in our panels? We have to upgrade our panels. These are all questions that need to be answered before upgrading your kitchen. But I will argue that your kitchen oftentimes is the thing that's making you money. So it's most important that you invest in that money maker and making sure that's the most efficient kitchen you can make it. And this is the best way forward. This is going to save you money over time, which we can touch on in a little bit. But what other solutions exist, right? Excuse me. Electric combi ovens exist, induction griddles, hot water heaters, fryers, broilers, tilt skillets, steamers, ranges, woks. You name it. There's nothing in a gas kitchen that doesn't already exist in their electric counterparts, including these traditional ways of cooking, like tandoori ovens and wok, and an induction wok. In fact, when you cook with a standalone wok, you are actually, if you have the induction version, saving about 500,000 gallons of water per year per wok. I've seen estimates as high as up to 750,000 to 1 million, but conservatively about 500,000 gallons of water per year per wok is what you'll be saving. That's a significant amount of money, especially if you're over on the West Coast, which I see some of our attendants are. Water is increasingly scarce over there on the West Coast, so it's important that we are conserving what we have. And this is a way of allowing us to still continue with our traditional ways of cooking while also being good stewards to the planet. It's a way of doing both, walking and chewing gum at the same time, if you will. Now, what is the operational differences between this gas range and the induction range? Now, I said before that the gas range is probably at most around 35% efficient. Truth be told, that in the field, it's somewhere in the high teens, low 20s, because we don't kind of The way that they get the efficiency rating is by rigorous lab testing. And let's be honest, chefs are not scientists. Oftentimes, for us to turn things out faster, we'll have all the burners on with, with stacks of pans on top of them, so we can quickly get these pans going, get them hot, and get the tickets out. It's not uncommon for in the middle of a rush to have a stack of saute pans with one burner on high, so that way your pans are already hot and going, and you can just keep replacing those pans. That just goes to show how inefficient this equipment is. But let's throw that away. Let's imagine that this piece of equipment is actually a 50% efficient range. Well, it does not exist, but we're going to say it does for this argument. How does it stack up with the induction? So the 50% induction, the 50% efficient range, can cook 38.6 pounds of food per hour. It's going to need some time and elbow grease to clean, which all the while can cause burns and fires. If you haven't cleaned one of these, let me walk you through it. We will take these grates off after we scrub them down and put them in a pot. Excuse me, brain fog. And put them in a sink with some degreaser and hot water. We'll then take the burners off, put a toothpick through every single hole to make sure that they're properly cleaned out, and then put them as well into that sink with the greaser and hot water. Then we'll scrub down that whole unit, dry that off, pull the drip tray, which is located underneath these little knobs, pour the contents out, take the foil off, scrub that thing clean, dry that thing off, put new foil back on it, put the drip tray back in. Then we'll go back and scrub and dry the grates and the burners that were in the degreaser. We'll put that back together, and then we'll light the pilot lights. All that, if you do it right, probably 20+ minutes. If you go over to the induction, 90+% efficiency, as we talked about, which amounts to 70.9 pounds of food per hour, just nearly doubling the throughput that you would have with your gas kitchens. It's a lot easier to clean because there's no thermal sources of heat. Even if you spill cream during service or whatnot, hot soapy water will clean that thing. If you spend 90 seconds on it, you're probably taking too long. It's very quick and easy to clean, a lot safer to use, which means that not only are you nearly doubling the production that you can do, but you're also spending significantly less money on harmful degreasers and chemicals to clean, and less time on labor to clean your kitchen, which of course is a huge savings as well. Your wok, this is a traditional gas wok. This is about 100,000 BTUs at 90% efficiency. You can cook about 124 pounds of food per hour. This is a plug-in countertop hob, significantly smaller in size, and which means you can be a lot more versatile with it. You can cook on nearly the same amount at 117 pounds of food per hour. But what are the kind of comparisons between BTU and kilowatts? And what if you had the comparable size? Well, the 30,000 BTU range that I just showed you at 35% efficiency gets you about 10,000 BTUs to the food. The 5 kilowatt hob at 85% efficiency, lower than what I just showed you, got you 14,000 BTUs to the food, which is why we're able to cook more food quickly, because we're getting more energy into the food a lot faster. The wok at 20,000 BTUs to the food. If you look at the countertop one, got you 15,000, which is why it was so close. But the standalone one that I showed you earlier got you 35,000 BTUs to the food, nearly doubling the amount of power you get into that wok, into that food, which is why we can increase production so much faster. So, cost comparisons. What's this going to cost to run? Well, if you're going to operate your kitchen, here's some assumptions: at 360 days per year for 15 hours a day, and you're paying $1 per therm, which means $1 per 100,000 BTUs, coming into your kitchen, or 17 cents per kilowatt hour, you're going to be paying $1,123 a year to run your gas range, and $1,114 a year to run your electric range. Now, that's not to say, hey, go induction, we're going to save you $9 a year. It's to say that the cost of operation is roughly the same. So with this example here, there's a little bit we're a little bit deceiving here, because the cost of gas has actually almost doubled last year, and in fact in California has doubled again this past month. And the cost of electricity is actually nationally right around 14, 15 cents per kilowatt hour. So these numbers are actually wrong. It's actually cheaper to run your induction by a lot than it is your gas. And it's only going to get cheaper because we saw last year reports that said about 65% of the infrastructure, the gas infrastructure, is leaking methane, and it's going to be very costly to fix. And you know, and like most businesses, when you incur a cost, you pass that on to your consumers. So this is a huge cost. It's going to be passed on to consumers, which is why you're seeing gas prices steadily rise consistently. And we're expecting to see another near double nationally increase by the end of this year. So it's only going to continue to go up. And as the grid gets cleaner and cleaner, becomes more efficient, costs will eventually go down. So thermal comfort, how does this stack up for chefs? So the way we kind of quantify thermal comfort is by breaking it down to 3 pillars. One is things that we can't control, like Mother Nature. What's the air velocity and the humidity? What's the operative temperature, or what the building owner can control, the air temperature, the radiant temperature of the buildings, and what's the occupant behavior? What do you as an individual can control? The clothing you're wearing, the activity level, all of that contributes to thermal comfort. Now, ASHRAE did a study that tested over 100 kitchens for a week in all climate zones, and they compared between summer and winter conditions. And they developed thermal comfort, meaning that between 68 and 82 degrees Fahrenheit, depending on what the humidity was. And the only time a kitchen was comfortable is if they were prepping or cleaning, or if it was freezing outside. The truth is that most kitchens were far outside that window, some well beyond 100. And I have worked in kitchens that are even beyond that, where we have experienced up to 130 degrees plus. The truth is, when they put it together on a graph and they expected this to be the top end, you see kitchens blew that out of the water. They were actually a little bit shocked at the results that they saw. But what is the quality of life differences for chefs, for the person that's in the space? Well, this is what you would traditionally see. Big flames everywhere, chefs running around. In fact, we are at any given moment running at full speed with sharp objects and things that can burn us, all for the sake of feeding our guests. And in these spaces, we are trying to turn around tickets in 10 minutes or so, and we're feeding hundreds of people per hour, and it's a very stressful environment. And when you're working these conditions, you're running that fast, you're pushing yourself as hard as you can, and the condition of the kitchen is far beyond 100 degrees Fahrenheit. In fact, there was one time I looked down at my thermometer in my chef coat, and I saw that it was well over 130, 135 actually. And what that does to your body is just like a runner, like a marathon runner, like you will get sick after a while. And if anyone's been through conditioning training, you know that after a while, your body will just throw up. You will get sick. And what we saw was after a rush, we'd be clamoring to go to the bathroom to kind of do that. So that's what we're putting ourselves through. And there's been times where if I've drank too much water and my electrolyte balance has been thrown off, and then like my muscles get all tense. And I remember getting sent home actually because I was on the verge of having to get called an ambulance because the electrolyte balance was so off. So it's very inhospitable environment, if you will, for the hospitality workers. Conversely, though, as a chef who's worked in an electric kitchen, it's not even close. What we saw was that we were much more comfortable. There was less infighting, so we worked more cohesively as a team. For an open kitchen, as you're seeing, it was one where our guest satisfaction survey scores went through the roof, because when you're comfortable, your interactions with your guests are more comfortable. And if your guests are comfortable, they're happier. And everything just kind of worked. We saw a dramatic reduction in the temperature of the kitchen, which we'll go into in a second. And it was just like a night and day situation. I noticed that my mental health got better as well, which led me to being a better leader, as well as a better husband for my wife as well, because I wasn't so stressed at work. It was just things that you can't quantify are things that I experienced in these kitchens. Now, we also tested the kitchen, and we chose September 9th through 16th of 2019. Why that week is because it was considered the perfect summer week. It was between 85 and 90, not a cloud in sight, no storm clouds or anything like that. It was what you would consider, if you went on vacation, the perfect week to go. And what we saw was that the kitchen never hit 74 degrees Fahrenheit. In fact, it stayed somewhere around 70 to 72 on average. So it was actually cooler in my kitchen during production, next to my ovens, during service that entire week than it was outside in the perfect summer week. So we went from about 100 plus 130 to about 70. So it's a 60-degree drop. That's an insane amount. The difference is just, like I said, night and day. And what are the health considerations with combusting fuels in the space? Well, when you burn natural gas, you release things like carbon dioxide, nitrous oxide, sulfur dioxide, formaldehyde, particulates like soot and smoke and other PM 2.5, and also carbon monoxide. Now, we're going to focus on carbon monoxide because we have sensors in our homes and at work because we understand the dangers of carbon monoxide. So what is carbon monoxide? Carbon monoxide is an odorless and colorless toxin with typical outdoor concentrations are anywhere from 0.03 to 2.5 parts per million. Now, there are no indoor air quality standards in America currently, but the federal standards dictate that it cannot exceed 9 parts per million outdoors. So if it exceeds 9 parts per million, that's when the government comes in, everyone goes inside until they find the source of the contamination and they fix it. The problem is when you're cooking indoors and you're combusting fuels indoors, it can far exceed 200 parts per million, where symptoms of which are nausea, vomiting, headache, lightheadedness. Does it ring a bell from what I just talked about while I was a chef in one of those gas combusting kitchens? Complications of which are permanent brain damage, cardiac damage, and even death. Benefits of electrifying are a lot. Let's just recap here. First off, modified equipment, as we can see. This was taken by a colleague of mine over at Stanford University, where service is done. They were just breaking down, and the grill was still on because it has to be on because it has to get that metal hot. And if anyone shows up later wanting a burger, then you need to cook it because it takes so long for fire to get metal hot. It's just a cost of doing business, but you don't have to do that with induction. Reduces building emissions, which reduces environmental impact. Your operation is more efficient, which means you're going to save money on your energy and utility cost. Precision cooking controls, which means more consistency with your cook. There's a dramatic improvement in thermal comfort. They're going to extend the life of your pots and pans. It's easier to clean, which means you're going to save on chemical costs as well. It's faster throughput, increased productivity, which means there's an increased dollar per labor hour. In other words, the dollar that you're spending on labor hour, you're getting more back than you would in the traditional kitchen. Thermal comfort, which just talked about, and the improved indoor air quality, which is a big one. So home stretch here, myth busting. Now we're going to tackle some of these pervasive myths that I've heard pretty consistently in my career. The first is that you can't create quality food on induction, which is simply not true because the Fat Duck, one of the best restaurants in the world, led by Heston Blumenthal, cooks on induction. Noma, #1 restaurant in the world on the planet. So the best restaurant to exist that year, all electric. In fact, the Culinary Olympics and the Bocuse d'Or are actually all electric as well, which means that the international community decided that induction cooking is the standard by which the best chefs on the planet will be judged. And they cook on the highest level of cooking year over year. So that's a myth busted, right? This is actually my stand-in for chefs who are opposed to transitioning. And he's going to say things like induction cooking speeds are exaggerated. We just talked about how that isn't, how we can double our throughput. And we showed the science of how much energy is actually making it into the pan and all these things. So myth busted. Sauteing isn't possible on induction. And his thought is that once you lift the pan, it's no longer connected to the induction range. Therefore, how can it possibly stay hot? And the simple answer to that is once you lift the pan off the gas range, the fire isn't following the pan. How's the metal hot? Metal is just hot. That's just how things work. So it absolutely is possible on induction. They also, excuse me, they also say that the chefs and home cooks can't preheat their pans, therefore they can't properly saute. That's simply not true. I mean, it simply is true. You cannot preheat your pans because you don't need to preheat your pans, but the idea that you can't saute properly is ludicrous because all you need is a hot pan. Saute literally means to jump, which is why, you know, the action of sauteing is vegetables or whatever jumping in the pan. And all you need to do is get that hot. And I've done demonstrations where I've taken pots and pans out of the freezer with ice in them, dumped them, and then we put cold vegetables on top and started sauteing immediately. There is no lag, if you will, with this. Cooking with gas gives you more control, and that's the illusion of control that you get when you see a large or small flame. But the truth is, if I were to say, you know, braise me something on medium low, there's medium, there's low, what is that? But if I said braise it at level 2 or braise it at 180 for 6 hours, now we have consistency. There's a difference of 1 degree there that it oscillates between. There is no guessing on what medium low could be. And God forbid there's a, you know, someone opens a door and the swift wind comes in and, you know, the flame goes out. Now you're screwed. We've all had that happen to us at home and at work. Induction cooking technology does not accommodate wok cooking, which was a big one for a long while, but we show that that's clearly not the case. In fact, in China, Martin Yan, who's a big fan of induction cooking and actually cooks on an induction wok himself, said that in like Beijing and in Hong Kong, most restaurants going in are all electric and have been for some time. So this isn't, so the chefs who created wok cooking are all about it. Why aren't we? Finally, glass surfaces on the induction equipment will crack and warp because it can't withstand the professional kitchen setting. I mean, if you look at the chef, you see he's a big burly guy. So let's kind of dive into that a little bit further. Now, first and foremost, this is tempered ceramic glass. It's not glass, it's not tempered glass, which means it's very strong and it will not warp. The difference is tempered glass can withstand temperatures of up to 600 degrees Fahrenheit. Tempered ceramic glass can withstand temperatures well beyond 1400 degrees Fahrenheit, which we all know none of our ovens can get that high. And that picture is at the time of an actual 5-year-old surface, which you can see there's barely a scratch on it, and it's so clean you can see how clean my walls are from the reflection. So that's it, everybody. If you want to learn more about electrifying your building or electrifying kitchens, we are proud to say that we worked on this decarbonization guide with the William J. Worthen Foundation. It is a 100% free resource, and there's 6 or 7 chapters. Excuse me. Chapter 5, the chapter we worked on, which is all about kitchens, obviously. And it is the most comprehensive guide ever written on the subject. So we literally wrote the book on this, and we offer folks to go and check it out for themselves and share it with everybody. You can find the link to download it at forwarddiningsolutions.com under the resource tab. And feel free to share that with anybody you think could get use out of this. The last time the William J. Worthen Foundation wrote a guide was their water reuse guide, and it made it into the UN Library of Resources. So they're a very, very well respected nonprofit. And the only other guide that I saw written about electrifying your building only had 2 pages dedicated to kitchens. Our chapter alone is 65 pages. So you can see the difference in how much work got put into this. And it was written by industry insiders. It was written by myself, an architect, an engineer, and a couple of architects, and another chef who focuses exclusively on residential kitchen electrification. So you both have residential and commercial kitchen knowledge in there, and I highly recommend you go and check it out. And with that being said, questions? Oh, Rebecca, you're muted.
Thank you. It
Sure.
looks like we have one question in the chat from Janice, and the question is, does going with an induction cooktop and other electrified equipment reduce the hood requirement in any way?
So you need a hood system no matter what to operate. It's kind of mandated by law. Once you get over a certain amount of grease-laden vapor has to be exhausted. What we found is that the amount of makeup air, the amount of all these like all these things that needed to kind of suck the air out was reduced, which is why the check program specifically targets demand control ventilation, because instead of it just being on at full, at 100%, just sucking everything up no matter what, it will ramp up and down based on your usage. So at Chatham, for instance, ours did that by scanning the cooktops, and as it recognized temperature increasing, it will match that by going up in the amount of airflow. But it was also ramped back down once we were done. And it only met us by how much we needed. So there were times where we were running 90+% efficiency. So instead of being 100% working, it was only using 10% of the energy. So yeah, it could definitely reduce the amount of makeup air needed, the amount of air that's being pushed through, so long as you have a demand control unit and everything is set properly.
Great, thank you. And we have another question. This one is from Nick Brown. What is the tipping point switching over? Great when electric is expensive, but in Canada, this is largely not the case.
I'm sorry, can you repeat the question?
Yes. What is the tipping point for switching over? Great when, I believe that's electric, it's abbreviated, is expensive, but in Canada, this is largely not the case. Yeah,
I mean, the tipping point, it's not just a one-to-one comparison, right? It's the fact that your labor costs could go down because it spends less time cleaning. The fact that your utility bills are going down because you're not spending as much money on electricity to kind of replenish the air conditioning you need for the building. You're eliminating an entire utility in the form of gas. You're also reducing your water consumption. You're reducing your chemical costs. You're reducing all these things. So it's a lot more efficient on your building. So it's not just to say, hey, what's the one-on-one comparison between gas and electric costs? There's so much more that goes into it.
And then our next question is from Kevin Lugo. If a kitchen wants to upgrade but cannot do a full retrofit, which components would you suggest they do first? For example, wok, oven, cooktop, etc.
So the first thing I would recommend is the things that have the open flame. So the wok, the griddle, and the range. Those are things that are going to have the most radiant heat, because no matter how hard you try to exhaust that, you can have gale force winds in there, you cannot exhaust out radiant heat. So it doesn't matter how good your air conditioner is, how good your hood system is, reducing the amount of radiant heat in the space will reduce the overall temperature of the building, which will reduce, it'll be a trickle down effect, and then you can go from there. So highly recommend you go for your either your griddle, your wok, or your range. So those are the three big ones.
And I just want to follow up to Chef's response there. Those exact three same pieces of equipment, the wok, range, and griddle, are the three pieces of cooking equipment that we fund via the check rebate for converting to induction.
It's almost like we thought about it.
Yeah, maybe. I might have consulted you, Chef.
Great. So we have a few more questions trickling in. The next one is the Pennsylvania grid prepared for electrification? We have 2,500 MW shortfall anticipated in Ontario. So there are concerns of huge or high infrastructure costs for electrification in the future that will be passed on to the electricity consumer.
Yeah. So the thing is, we know that grids need to be upgraded, and we know that they're constantly being upgraded, right? Sometimes it takes something like what happened in Texas to kind of force people to make those changes, despite being told for over a decade, you need to make some changes. But the truth is that, like most things in the market, when there's a demand for it, the market will catch up and meet up with the consumer's demand. So you're seeing that we can walk and chew gum at the same time. We can create jobs and kind of get the grid growing and clean it up as well, as opposed to waiting. It's like, imagine back in the day when we were talking about horse and buggy versus car. We know a car is a lot more efficient to get to where you need to be a lot faster. But imagine saying, I'm going to wait until there was gas stations all around America before I started getting into a car. We were able to build out that infrastructure as folks bought cars. And this is gonna be the same way.
Yeah, and I'll follow up to that as well. I know that question was Canada versus the United States. And so I will mention President Biden's bipartisan infrastructure law, also known as IIJA, Infrastructure Investment Bill. So there's a lot of funding in the infrastructure bill to strengthen our grid in the United States and make it more resilient and reliable. So that work is definitely underway via the bipartisan infrastructure law.
Great, thank you. And then we have a question from Brittany. Can you share information about additional electrical load of electric kitchen equipment? So I'm not sure if this is something that we can provide, in follow-up, but if any.
Yeah, that would be something I would consult with an engineer or someone who does energy modeling. They'll be able to kind of take in the equipment that you want and see what those loads would be. Then they would be able to tell you, hey, your panels can handle it, or you should upgrade your panels, whatever the case is. But that's something that I would consult with an expert. More specifically, but typically you'll see the equipment are going to have about like a 208 single or 3-phase, depending on what you're going to be doing. If you're doing a lot of cooking, I would suggest staying in the 3-phase range, but I would definitely let an engineer take a look at that for you.
Great, thank you. And the last question that we have come in is, have any comparisons been made over time to look at maintenance costs between gas and electric, with gas systems seeming to be much more simple?
It is much more simple. Truth is that the average replacement rate of a gas range is somewhere in the 10 to 15 year range. And overseas, we're seeing somewhere to 8 to 12. So it's pretty similar. As far as comparisons done in this country, unfortunately, that hasn't been the case because it is so new in this country. But we're going to change that. In fact, we're actually looking into doing a different kind of study with PSC Energy. That is, I'll stop sharing my screen.
Sure. Just going to pop this up for a sec. Thank you.
Yeah, that we're going to be doing a study looking specifically at all sorts of things relating to the kitchen, including exposure rates to the restaurant workers. We're hopefully we'll be able to answer some of those questions as well, but that won't be ready for another year or so.
Perfect. And then we have one last question that came in from Kevin. Utilities also have energy efficiency programs. First, Energy PA has incentives available that would reduce KW/KWH in the kitchen through HVAC, lighting, and refrigeration measures. So that might have been more informational.
Yeah, that was definitely great information. Yeah, and that's the thing, like in New York, for instance, right now you're looking at 69.1% of the grid is ran by gas, right? So if you were to transition, you would still be using gas to kind of take care of your kitchen. The truth is that you'll be using it more efficiently, which is about 85% of the grid as opposed to the 30% in your kitchen, but it would still be that. But over time, that grid will be cleaner. Over time, it'll be more efficient. And over time, your kitchen will then be more efficient, will be cleaner. It will be, doing better for the planet. The truth is that in every city, about 70% of the carbon emissions come from buildings. And the truth is that the EUI of any commercial office building is about 30. But the average cafeteria style basic gas kitchens is 325. They're from 250 to 400, but still, it more than 10 times of the energy use of any building is going to be in the kitchen. So it stands to reason that the kitchen needs to be one of the things transition to be more efficient and to producing less pollution in order for us to bring down our carbon emissions in our cities, which is why we're talking about kitchen specifically. Obviously, I'm biased, but the facts support it.
And our last question that came in from Devin is, what are some of the main brands that make electric equipment?
Commercially, there are two that I love to kind of play with here in America, which is Garland, which is owned by Convertherm, which is actually the company that supplies all the commercial equipment for like the Olympics and the Bocuse. and also like Cooktech. They are actually manufactured in America. Rationale manufactures in Norway, but they're actually an amazing company. Electrolux as well, and another one that I'm a big fan of is Alto-Shaam, because they also manufacture in America. But that doesn't mean that they're all doing induction. It's just they're all doing electric equipment, and they're all doing it well.
Great, thank you. So with that, that'll conclude the question session. And I just wanted to briefly go over some volunteer opportunities here in Central PA. We are always seeking volunteers. There are many ways to get involved, whether that be through our various committees such as Women in Green, Lead Advancement, Advocacy and Policy, or even joining as a Market Leadership Advisory Board member. So we will share more information and follow up with that. And if you're zooming in from another location, we have many communities within USGBC across the nation. So please feel free to reach out with any questions about that as well. And then lastly, I'd like to thank our annual sponsor, First Energy. And if you're interested in becoming an annual or event sponsor, you can reach out to myself, Rebecca Bentley, and I can provide some more information on that. And I just wanted to give a huge thank you to Heidi and Chris for their presentation today. This was great. If anybody has any questions that come up in follow-up, you can reach out to me and I can get you in touch with Chris and Heidi, but I also will be sharing their contact information in follow-up as well. And all of the resources that we provided today in the chat will also be available in our follow-up email. But thank you, everybody. And once again, if you have not already sent me your GBCI or AIA number, please email me. I'm happy to double check for you. And thank you all so much for attending.
Thank you, everybody.
Thank you. Take care.